Welcome. Today I'm going to sit down and take a look at the SAT math prep on Goodnotes 6. I recently just got on Goodnotes 6 and I discovered this math prep last night and I've just been so excited about it. So I figured my first time actually diving into it, I'd make a video of it. No idea if anybody actually wants to see this or will watch this. But if you do want to see more of this content, either these videos be longer or more frequent, please let me know. So I'm just going to walk through, leave a comment, and just indicate like if this is worth doing or not. But I'm going to be working through a lot of these problems, just more of a hobbyist. But I have no problem recording it and throwing it up in my channel. So there is a SAT math prep option in Goodnotes 6 where they have 4 different categories. So there's categories of Heart of Algebra, Passport to Advanced Math, problem solving and data analysis, and then additional topics in math, where then within each category there's topics, as you can see. Then within each topic there is easy, medium, and hard difficulty. I don't know their definition of easy, medium, or hard. I have not done any of these problems yet. This is going to be my very first time sitting down and doing some of these problems. So what I figured I'd do is I would just do 2 easy, 2 medium, and 2 hard. And I wanted it to be random. I couldn't find any really like random. There's like some start practicing, but it doesn't need a certain topic. So I just used the random number generator. I listed the categories 1 through 4, and then I just pulled a number 1 through 4 using a random number generator. And then within that category, I picked, if it was Heart of Algebra, I picked 1 through 9, Passport to Advanced Math 1 through 14. So I pulled 6 problems, 2 easy, 2 medium, 2 hard. So let's just jump into it. First one I picked for my first easy was category 2, Passport to Advanced Math. Problem number 3, which is going to be equivalent expressions using rational exponents, radicals, simplifying, and other forms. So topic 2, problem number 3. So let's do it. Easy. Which of the following expressions is equivalent to 27 over 8 raised to the 2/3? Alright, let's do this. So we have 27 over 8 raised to the 2/3, so just a nice little rational exponents problem. We could rewrite this as the cube root of 27 over 8 being squared. Move this up a little bit. So the cube root of 27 is 3, cube root of 8 is 2, and then that's being squared. So 3 squared is 9, 2 squared is 4. So 9 over 4 is what I'm coming up with. Let's see. I'm saying that one. It looks like there's a math assistance. I'm hopefully not gonna use that because it doesn't come to that point. And there's also hints that you can use at the top right there. But I'm saying 9 over 4. Let's check it. Correct. Cool. Question 1. Done. Next one I pulled for my easy, topic 3. So that would be problem solving, data analysis. And then question number 4. So question number 4 would be 1, 2, 3, 4. Scatter plot linear, quadratic, or exponential models to describe how the variables are related. This sounds tough. Which of the following models is best suited for describing a relationship between 2 variables when the relationship is not well defined and there is no clear pattern in the data? So it doesn't look like we have to actually do anything other than just know some definitions here. So scatter plot is what I'm thinking, just as my first linear model. No, linear. Most should have a clear pattern, quadratic, exponential patterns. So let's say scatter plots. I'm feeling that one. Yes. 2 for 2. All right. Easy was, I mean, if you don't know stats, I could see that being pretty difficult. So definitely good review there. Let's see. For my mediums, first one, category 3 I pulled. So which one is that? That's the same one we were just in. Question number 2. So topic 3, or category 3, question number 2. Single multi-step problems involving percentages. Now we're on medium, so let's check this out. Practice. If 30% of x is equal to 40% of y, and y is equal to 25% of z, what is the ratio of x to z? Right off the bat, I don't know. Let's just start setting up some things. So if you're ever in this situation where you don't know, just start writing things down. So 30% of x is going to be 0.3 times x, and that's equal to 40% of y. So let's say 40% of y. And then they're saying y is equal to 25% of z. What is the ratio of x to z? So it looks like we just have to use some substitution here. So let's just substitute in y into that first equation I wrote down. Let me try to zoom this in a little bit. So we're going to have 0.3x equal to 0.4 times 0.25z. And then we can multiply. I don't see any rules about calculators or anything, and I want to play it safe. 0.4 times 0.25 is going to be 0.1. So we have 0.3x equal to 0.1z. Let's check out our answers here. 1 to 2, 1 to 3, 4 to 3, 3 to 10. So we want to drop this down. So if I divide by 0.1, that's going to be, what happens if I, yeah, it's going to be 3x equal to z. And we want x to z, so that would be 1 to 3. Yeah. Nice. Yeah, some of those, like, with percentages and like ratios and stuff, like the conversion is really weird sometimes. Let's just kind of curious. Let's see what it says about hints. So I got this one right. So it says set equations, basically given information. So they set up the equation for you, solve one variable. Second equation, so they plug in just like how we did, and then we get 0.3 equal 0.1. Divide both sides of the equation by their common factors, and then we get 3x equals z. That's what I got. And then the ratio of 1 to 3. All right, nice. Let's move on to the next one. So in my next medium difficulty, I pull topic 1, question 1. This is medium. Solving linear expressions or equations in one variable. Oof. The outcome of increasing p by 84% is the same as decreasing 2p by 12. What is the value of p? So we're taking, zoom this in, taking p and increasing it by 84%. So my confusion is 84% of p or just 84%? The outcome of increasing p by 84% is the same as decreasing 2p by 12. What's the value of p? I know this is like a silly thing to get caught up on, but and the outcome of increasing p by 84%. It's got to be of p. It's got to be p plus 0.84p. It's got to be. Let's try that out. Let's see what happens there. So that's going to be 1.84. Let's just try this out. I'm not feeling super great about that. I don't like that way that's worded, but that's okay. 2p minus 12. I could be wrong. Let's subtract 1.84. Let's add 12. So I'm going to add 12 over. Then I'm going to also subtract 1.84p. This could be like a really silly mistake on my part. Let's see. So I had 12 subtracted, so 2p, 2 minus 1.84. And we get 12 equal to 0.16p. 12 divided by 0.16. 75. So I divide by 0.16. So p equals 75. Let's check. Let's see if that answer is there. That answer is there. I think that's right. But just out of curiosity, let's see if they try to throw us off. Like, let's see if that, for my first equation here. So I'm going to try to solve this just to kind of see. I'm pretty sure that my answer is 75, but I'm really just curious now. So I'm going to subtract p, add 12. Yeah, 0.84 plus 12. Yeah, 12.84. Okay, it's 75. Yeah, sometimes I got a little bit caught up on that wording there. I don't know. Yeah, 75. Correct. Probably silly of me to get a little bit caught up on that wording, but sometimes, you know, you want to be very specific. All right, not bad. What are we, 4 for 4? That was a good question. I like that. I'm always, percentages, like I said before, percentages are always a little bit weird. So good practice. All right, so now we're into hard. First hard category was the heart of algebra. And then we got question 7. Topic 7. 1, 2, 3, 4, 5, 6, 7. Algebraically solve systems of 2 linear equations in 2 variables. And these are hard. Let's see if they're hard. Ooh, word problems. If a car covers a distance of 4 miles in the same amount of time as a bike covers 2 miles, and the car speed is 3 units faster than the bike speed, what are the speeds of the car and the bike? So whenever you're in a situation where you're trying to solve these word problems, like, just start writing things down is always my go-to thing. So if a car covers a distance of 4 miles, we have a car, we have a car, and it's gone 4 miles. We have a bike, and that has gone 2 miles. Then car speed is 3 units. So we have a distance equals rate times time problem. So I always like to go to tables here. So distance equals rate times time. So let's create a table. And we are dealing with 2 pieces of information. We have a car and we have a bike. Now let's just start filling in information. So the car goes 4 miles. The bike covers 2 miles. The car speed is 3 units faster than the bike speed. So we don't know the bike speed. Doesn't give us any information about the bike speed. So I'm going to call that x. And the car is going 3 units faster. So x plus 3. And then the time, we don't know, but we do know that the car and the bike, it says right here, if a car covers a distance of 4 miles in the same amount of time, can I mark this up, by the way? No, I can't. Covers the same amount of time as a bike covers 2 miles. So times are equal. So if we have the formula distance equals rate times time, and I'm not given time, I could just solve for time by dividing by rate. So time equals distance over rate. So that means time here for the car is going to be the distance of 4 over x plus 3. And then the time for the bike is going to be 2 over x. And we just set up an equation here. We are going to say the times are equal. So car time, 4 over x plus 3, is equal to the bike time, 2 over x. And then solve the proportion. So 4 times x is 4x equal to 2 times x plus 3. Solve for x. So 4x equals 2x plus 3. Oh, sorry, plus 6. I'm like, wait, something's not looking right here. Plus 6, plus 6. 2 times 3 is 6. Subtract 2x. So we get 2x equals 6. Divide by 2, x equals 3. Now, x equals 3, but that is not our answer. Because we always want to make sure we read the question accurately. It says, what are the speeds of the car and the bike? So if I got x equal to 3, what is my x? I called x the bike. So the bike is going 3 units. And the car is going 3 plus 3, which is 6 units. So the bike is 3, car is 6. Let me just double check. Covers a distance of 4 miles, same amount of time, bike covers 2 miles. It's 3 units faster. 4 over x over 3. 4x, 2x plus 6. So 3 and 6. Nice. Okay. Good question. Definitely a really good question. Last one. I picked topic or category 2, passport to advanced math. And then question number 5. Let's see. 1, 2, 3, 4, 5. Solve a quadratic equation having rational coefficients. Oh boy. Hard. Find the roots of the quadratic equation if the product of the roots is 13 and the sum of the roots is 18. Look at those answers. All right, here we go. Find the roots of the quadratic equation if the product of the roots is 13. So I have product of two things is 13, the sum of two things is 18. Let's just go with that. Let's just start at that point. Let's just use that as a jumping off point here. So I'm going to call it x, x and y is equal to 13, x times y, because the product is 13. And then they're saying the sum of the roots, so x plus y is equal to 18. And then let's just go with solving. So I'm going to substitute in. I'm sure there's a very different approach to this, but this is just what's jumping out to me. So now I'm going to substitute in my y in this equation here that I generated. So I'm going to have x times 18 minus x equals 13. And let's just start solving. 18 times x is 18x minus x squared equals 13. So we want to get positive x squared over and then factor. That's going to be rough factoring. We can tell from the answers we're going to get something a little messy here. So let's add over x squared and subtract over 18x. So I'm going to get 0. Whoops, got the eraser here. So I'm going to add over x squared. I'm going to subtract over 18x, add x squared, subtract 18x. Let me go over here. So it's going to give me 0 equals x squared minus 18x plus 13. Can't factor it, so we got to use quadratic formula. I'm just going to go with. So quadratic formula is negative b plus minus square root of b squared minus 4 times a times c all over 2a. All right. This is going to be positive 18 plus minus square root 18 squared. I'm not gonna chance it here. 324 minus 4 times 13 is 52. 324 minus 52 is 272. So 18. This is all over 2. Just kind of. This is looking a little rough, but hopefully we're okay. And those answers looked rough, so I think that means that we're pretty good shape. So let's say 18 plus and minus square root of 272 all over 2. So now we got to simplify 272. And I'm going to use a little bit of a cheat. All these answers have root 17. So let's just take 272 divided by 17. And that's 16. Cool. So 272 is 17 times 16. Square root of 16 is 4, so 4 root 17. So we're going to have 18 plus minus 4 root 17 all over 2. Factor out 2 from, because we're going to have 18 plus 4 root 17 and 18 minus 4 root 17. So let me just set that up. I don't want to take any shortcuts. A lot is on the line right now. This is very serious. So I'm going to take 18 plus 4 root 17 over 2, 18 minus 4 root 17 over 2. Factor out 2. So I'm going to have 2, 9 plus 2 root 17. And then 2, so 9 minus 2 root 17. So we get 9 plus 2 root 17, 9 minus 2 root 17. 9 plus 2 root 17, 9 minus. There it is. Right there. Correct. Okay. Well, that was all 6 that I wanted to do. This was a lot of fun, actually. These problems are really good. Like, I think the easy, medium, hard, I definitely see that there was a step up in the level of difficulty. I think that distance equals rate times time problem is a little bit in my wheelhouse because I teach that a lot in intermediate algebra. So maybe I got lucky with that one, especially with this last one that I just did. That was not super easy or anything. That was definitely hard, but we got it. So again, I hope you enjoyed this content. Let me know if you want me to make more of these, make the videos longer, make them more frequent. I don't know. Just trying it out.